Hello dear students, I welcome you back on lecture number 3 on the topic electric charges and field. So earlier in this topic we had studied what are the charges and what are the properties of the charges, and also we were able to understand Coulomb's electrostatic force of attraction or repulsion. Along with that also we have studied permittivity, what is absolute permittivity, what is relative permittivity, yes or no. So if you remember in Coulomb's law we had considered 2-point charges Q1 and Q2 separated by a certain distance r, and among these charges there was electrostatic force of repulsion because the nature of charges were similar. Okay, if it was minus then they would have undergone attraction. So how does the force was varying? Product of the magnitude of the two charges, that is Q1 Q2, inversely proportional to the square of the distance, and if I remove that proportionality constant and made it K, which is known as electrostatic force constant, whose value was supposed to be 1 upon 4 pi epsilon naught, which was depending upon the medium, right? But what if third charge comes into existence here? Maybe a charge namely plus Q3 comes into existence. So what will be effect on this charge, or what will be effect on this charge, that we are going to study today. Or suppose one more charge namely Q4, maybe minus Q4, what will be effect on this charge because of this new charge that we are going to study today. So our title for today's topic is force between multiple charges. So same electrostatic force, that Coulomb's force only we are going to apply, but here now for the multiple charges, here we have more than two charges, right? So in order to understand force between multiple charges, first we need to understand principle of superposition. So I hope some of you might remember in first year you had studied principle of superposition. Do you remember the name of the topic? Where did you study? So in waves topic you might have come across this concept, principle of superposition. Now what does it states? Let me give the statement first here. Force on any charge, force on any charge, or force on a charge, I would write force on a charge due to any other charge is vector sum of all the other forces on that charge, vector sum of all the other forces on that charge due to all the other charges. Now it's quite easy. Okay, what it states, force on any charge. Imagine any force, imagine any charge. Okay, let me give a name plus Q1. The force on that charge due to any other charges at certain distance is vector sum of all the other forces on that charge due to all the other charges. Are you understanding what I am trying to tell you is? See here, let me erase this. Just remember the statement. Force on a charge due to any other charges, maybe n number of charges, will be equal to sum of all the forces on that charge due to all the other charges. Let us understand the statement. Okay. So suppose there is one charge plus Q1, and this charge is been at certain distance r, and here it is my one more another charge Q2. Now within this charge there will be electrostatic force of attraction, repulsion. They will go away from each other. This will suffer a force F12, this will suffer a force F21. Force on 2 due to 1, force on 1 due to 2. But what if third force comes into existence here? Maybe somewhere here, Q3. So as I told you, Coulomb's law is central force. So there will be again electrostatic force of repulsion from this. One more charge minus Q4. Here will be electrostatic force of attraction. So force on this single charge will be equal to vector sum of all the other charges. vector sum of all the other forces due to these charges. This is principle of superposition. Are you understanding? Like you are supposed to, you have been given one task to pick up one stone. Okay, pick up one stone from the on the earth. Okay, on the land, one stone is been placed, and that stone is so huge that you alone cannot lift that stone. So what you do? You take help of one more person. Then he is also unable to do it. Both together are unable to do it. Then you take help of third person, fourth person, fifth person. At certain point of time, all together can easily lift up that stone. So why that stone is been lifted up? Because the net force acting on that stone has increased. Why it has increased? Because of the so many peoples. So here net force on this charge, similarly it has enhanced. Why it has enhanced? Because of the number of other charges. But principle of superposition tells us most important thing. See here, there was an electrostatic force of repulsion within these two charges. Plus Q1 was repelling with plus Q2 with certain magnitude and in one particular direction. They were going away from each other. But if third charge, forget this Q4 for time being. Okay, I have just three charges. Q1. This is plus Q1, this is plus Q2, and this is plus Q3. Now this another charge has come into existence. So now two charge system has become three charge system. So I call it as what? Multiple charges. So now if this third charge comes into existence, are they going to affect the force within these two charge particles? No. You have to learn something from electrostatics. See here, the arrival of the third charge will not affect the force within the initial two charge particles. So this is called principle of superposition. Now let us find an expression for the forces due to multiple charges. Now consider 3-point charges Q1, Q2 and Q3 separated by a distance R12 from Q2 and R13 from Q3. Okay. Now we are going to find the net force on this charge particle due to these two charges. So here which law will be valid? Okay, here we are going to use again simple principle of superposition. So what does it states? The net force acting on this charge particle will be vector sum of the two forces due to these charges on this charge. Okay, so first you write the consideration. What consideration should be written? Consider 3-point charges Q1, Q2, Q3 separated by a distance R12 from Q1 to Q2, R13 from Q1 to Q3. And here we are interested to find net force on that charge Q1. Okay, now the force on Q1 due to Q2. The force on Q1 due to Q2, what it will be? F12 will be equals to 1 upon 4 pi epsilon naught Q1 Q2 divided by R12 to the square R12, where R12 is a unit vector. So the force on Q1 due to Q2 will be what? 1 upon 4 pi epsilon naught Q1 Q2 divided by R1 square into R12, which is in the vector form. Similarly, the force on Q1 due to Q3, what it will be? F13, that will be equals to 1 upon 4 pi epsilon naught Q1 Q3 divided by R13 the whole square R13. Now students, look carefully here. Here just we are using Coulomb's law. So force on Q1 due to Q2 will be 1 upon 4 pi epsilon naught Q1 Q2 divided by R12 square. And similarly, force on charge particle 1 due to third particle will be 1 upon 4 pi epsilon naught Q1 Q3 divided by R13 the whole square into R13. So the net force acting on this charge particle Q1, F1, I'll write F1 will be what? According to principle of superposition, vector sum of the two forces. So F12 plus F13. Yes or no? So this is simple superposition principle. So just go on adding this. F1 will be what? What is F12? 1 upon 4 pi epsilon naught Q1 Q2 divided by r12 the whole square, r12 vector 1 upon 4 pi epsilon naught q1 q3 divided by r13 the whole square into r13, which is a unit vector. Let me change the marker here. R13. Now, students, look at that equation. 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught, it's common, right? Whereas q1 is also common and q1, yes, that's it. So what I will do is, I'll take this term outside. What will be inside the bracket? q1 1 upon 4 pi epsilon naught. So what I did here, I took this term common, 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught. Here q1 is common, q1 is common. So on up to n number of turns. So here what will be inside? q2 r12 the whole square into unit vector of r12 plus q3 r13 the whole square into unit vector r13. Yes or no? Now, shall I erase this? Okay. So, just look carefully here now. Now, if I go on expanding this equation, so this equation will hold good for n number of turns. Q2, Q3, Q4, Q5, Q6 and so on up to Qn number of turns. So for n number of turns, what will I get here? If Q1, Q2, Q3 so on up to Qn, what will be net force acting on this will be? F will be equals to F1 plus F2 plus F3 so on up to Fn. Yes or no? So now I will generalize this equation. Now, so total force on this charged particle F will be Q1 4 pi epsilon naught. Now, it's a vector addition. Go on adding the terms. For n number of terms, how this equation will be valid? So either I can integrate it or summation it. So what I'll do, I'll better use summation. Now summation I equals to, what I should be equals to 2 up to n number of turns. Why 2? Because here already I have one particle Q1. So for n number of turns I will be equals to 2. So this will be equals to Qi divided by R1 I the whole square R1 I the unit vector. So this is the net force due to multiple charges. This is the net force due to multiple charges. Are you understanding? So this is the net force on the multiple charges. So what did I get?